Hi everyone, today we're talking about how you can use Pythagorean theorem to find area and perimeter. As a reminder, you do not need to write down everything we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause to jot down important notes, rewind to view information again, and fast forward if you think you got it. But don't fast forward too much that you end up missing out on something important. So as a review, the Pythagorean theorem, it says that a squared plus b squared equals c squared, where a and b are the legs. Hypotenuse is the longest side across from the right angle, and it only works for right triangles. Today you're going to be using the Pythagorean theorem to find area and perimeter. So be sure that this is in your notes. Area is the amount of space inside a flat two-dimensional figure inside. And for a triangle, you're going to multiply and divide to find the area. You're going to multiply the length times the width and divide that by 2, because if you remember, a triangle is half the area of a rectangle. It's just split up. And for area, your answer is always going to be squared. Centimeters squared, inches squared, etc. Because you have a two-dimensional figure and you're multiplying those two dimensions of length and width. For perimeter, it's the combined length of the sides or rim of a flat two-dimensional figure. And the word rim is in perimeter as well, so that's the outside lengths. For that, you're going to add up all the sides. And that that answer is going to be in centimeters or inches. So no squared or anything like that. So it could be feet, miles, what have you, because you're only adding up the lengths. So for perimeter, it's only the length, while for area, it's the length and the width. That's why you have two dimensions and the units are squared. So again, make sure this is in your notebook, and we're going to go over some examples. All right. Knowing that perimeter is adding up all the sides, go ahead and pause this video and try it on your own first. Okay, so in this problem, we need to find the perimeter. Perimeter is adding up all the sides, so it's adding up a plus b plus c. I do have two of those sides by counting 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 units. For one side, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then I have 15 units. And I'm not sure what C is, and that's because this is slanted, so they're not full units. I can't count them. So I don't know what that answer is yet. I do need to figure out C. So I'm going to use my Pythagorean theorem to figure that out. A squared plus b squared equals c squared. I can label A, B, and C on my triangle. 15 squared plus 8 squared. Still trying to figure out what C is. 15 times 15 I will put in my calculator. That's 225 plus 8 times 8, 64 equals C squared. When I add those two together, I get 289, and so C squared is equal to 289. C by itself would be equal to the square root of it. Let's see, does 289 square root? Yes, it does, to 17. So now we know that C is equal to 17 units. So using Pythagorean theorem, I can find out the missing side, which is what I needed for my perimeter. So now I can add up 17 and 15 and 8, and I'll get 40 units as my perimeter. All right, so that's what you have to do to get that answer. requires you to do a little Pythagorean theorem to figure out that missing side. Other problems will require you to do something similar. This one looks very tricky because you actually only have one side that's missing, or sorry, one side that's given. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 units, right? And you don't have a right triangle, if you notice. So I can't use Pythagorean theorem if I don't have a right triangle. Here, this one's a little tricky. You're going to have to create a right triangle. I can cut this triangle in half. So now I have two different right triangles. So if I were to use a squared plus b squared equals c squared, my Pythagorean theorem, I would have to use half of this isosceles triangle. Isosceles just means two sides are equal. Okay, I feel like the more I trace, the uglier it gets, but you get my point. I'm going to use this one now, okay? So this will be, let's say this is my A, this is my B, and this is my C, because this is a right angle. So I've created myself a right triangle. So now I can use that to figure out a missing side. I can use it to figure out C, because I can figure out A by counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This side is 12. This side, tricky, it's only half of it, so it's going to be 5. Okay, this whole side was 10, so half of it would be 5. So now if I were to use Pythagorean theorem, I have A is 12, 12 squared, B is 5, because it's only half of that, we cut it in half, to figure out our C. C is the same side. So this is 12 times 12, 144, plus 5 times 5, 25, equals C squared. 144 plus 25 is 169, whoops. C squared. To figure out C, I need to square root both sides. So I need to find the square root of 169, which is 13. So now I have this side as 13. So I have a 10 on the bottom. If we were to redraw it, it's 10 on the bottom. We found 13 here. And we can assume that this side is also 13 because it's an isosceles triangle where both sides are the same. And then I can add those up, which will give me 13 plus 13 plus 10 as 33 units. Okay, that wasn't my bad. 10 plus 13 is 36, not 33. That's why I got that one wrong. Okay, silly mistake. Okay, on to another one. Area is the other type of problem that we could ask you. And in this problem, they're asking for the area of the right triangle shown below. So we have the area of a triangle. The formula is length times width divided by 2, if you remember. Now keep in mind, length is how long your triangle is, and width is how wide your triangle is. So this one right here is not the length or the width, the slanted one, the hypotenuse, not the length or the width. Length is how long from one side to the other, width is how wide from one side to the other. If it's slanted, it's not going to be an appropriate length or a width. When you go to the doctor's office and they want to measure how tall you are, you don't stand sideways, right? You stand up, tall. Just like how if you were to measure a shadow, you go from one side to the other. You're not going to measure the shadow starting from the building and then to the ground, right? So it's got to be straight up and down, or left to right. Using that information, pause the video and try this problem on your own. Okay, that should have been a hint to you that you're not going to be using this number in your length times width later. However, you do need it to figure out this value. We need basically this value and this value. We only have one of them. So we do need Pythagorean theorem to figure that out. A squared plus b squared equals c squared. This one is our c, and it doesn't matter what we label the other two as. A is 1.5 squared, plus we don't know what the b is. C is 2.5 squared. So in my calculator, I'm going to look for 1.5 times 1.5, which is 2.25, plus b squared, equal to 2.5 times 2.5, that's 6.25. Then to solve for b squared, I'm going to need to subtract 2.25 on both sides so that I can get b squared on its own, and I'll end up with 4. b would be the square root of 4. That's a perfect square because 2 times 2 is equal to 4. So now we got that b is equal to 2. Length times width wants these two numbers multiplied together, the ones that make an L. So that'll be 1.5 times 2 divided by 2. Doesn't matter the order, to be honest. If you have 1.5 times 2 versus 2 times 1.5, it's going to be the same thing. Multiplication, the order doesn't matter. Now here I'm going to do something fun, and by fun it's not really that fun. Instead of putting all this in my calculator, I notice I have multiply by 2, and then I also divide by 2 later. So to kind of save some unnecessary work, I'm just going to cancel out those two, just like in algebra. Multiply by 2 and divide by 2 is going to give you the same answer at the end anyways. So the answer is 1.5 units squared. Now the reason why it's units squared is because this was 1.5 units and this was 2 units. So units times units was units squared. So that's why area problems give you squared units at the end, because the units themselves are being multiplied. So the answer is 1.5. Again, you could have also put this in the calculator, 1.5 times 2, and then divide by 2. You're still going to get 1.5 at the end. So area, that's the one thing I have to caution you about, is that the length and the width are not always going to be the numbers that they give you. If it's a slanted one, that's neither the length or the width. Let me know if you have any questions as you work on these problems, and I'll see you in class.